Hey everyone, and welcome to today's Explainer. You know, every single time you pick up your phone, crack open your laptop, or stream a movie, you are heavily relying on this massive, invisible infrastructure that basically powers our entire digital lives. So today, we're going to decode exactly how that works by looking at the true foundation of modern applications, client-server architecture. Let's get into it.
Okay, I want you to pause and ponder something for a quick second. Think about what literally happens the exact millisecond you tap an app icon on your screen. Like a vibrant feed of photos just appears, right? Or a high-def video instantly starts playing. But where is all that data actually stored? When you hit play, where does that video actually come from? Who or what is doing all the heavy lifting behind the scenes to make that content just magically appear right there in the palm of your hand?
Let's ground this in our daily reality. Think about your everyday actions. Opening Instagram, streaming YouTube, sending a quick WhatsApp message to a group chat. We totally take these things for granted. But these seemingly instantaneous actions actually rely on an immense amount of data moving thousands and thousands of miles across the globe. And it's all happening in literal fractions of a single second. It is this highly coordinated, crazy dance, and it's all made possible by one very specific structural model.
Section 1. The mechanics, clients, servers, and communication.
So, back in the early days of computing, machines were basically total loners. If you wanted a file from another computer, you literally had to physically carry a floppy disk over to it. Obviously, that wasn't going to scale as the world got more connected, right? The brilliant solution was the client-server model. It brought order, scale, and seamless communication to all those disconnected machines. Now, first up in this model is the client. The client is simply the asker. It's your phone, your web browser, your smartwatch. Crucially, the client doesn't store the massive data files, and it doesn't do the heavy processing. A really great way to think about this is like a hungry customer walking into a restaurant. The customer doesn't go back into the kitchen to cook the food or chop the vegetables. They just look at the menu, place an order, and wait to be served.
And naturally, that brings us to the other half of the equation, the server. The server is the responder. Sticking with our restaurant analogy, the server is the kitchen. It takes the order from the client, cooks the meal, which in the tech world means processing the data, and sends it right back out. And here's the thing, the server works entirely independently of any individual customer. It's just sitting there, highly powered, always on, constantly listening for requests and pushing out the resources that those clients are asking for. Now, it's pretty important to note that not all servers are exactly the same. Just like a massive high-end restaurant has different kitchen stations, one for grilling, one for pastry, large digital platforms need specialized servers. Web servers deliver the actual pages you see. Application servers handle all the complex business logic and the heavy math. Database servers safely lock away your user profiles and data. And then you have mail and file servers handling their own specific jobs. Massive platforms use a combination of all of these, working together in perfect harmony.
All of this activity builds into what we can basically call the communication heartbeat of the internet, and it happens in 5 distinct steps. First, you tap your screen. Boom, the user sends a request. Second, that request gets packaged up and literally travels through the network, sometimes across oceans. Third, the server receives it and processes it. Fourth, the server packages its response and shoots it right back. And finally, your client interprets that data and displays the result on your screen. Request, response. This exact 5-step heartbeat is pulsing billions of times a second worldwide.
Let's apply this to a real-world example we literally all do. What actually happens when you open YouTube? Well, you type the address, and your browser gets the request ready. That signal leaves your house, bounces through a bunch of internet service providers, and eventually hits a massive Google data center. Those servers instantly authenticate who you are, query the database for your specific personalized algorithm, package up all the thumbnails and video links, send them flying back across the internet, and your browser paints the screen. All 6 of those complex steps, they happen in under a single second. It is absolutely mind-blowing when you think about it.
Section 2. Scaling up, the architecture tiers.
Okay, so that's the basic back and forth. But how on earth does a massive company like Google or Netflix manage this for hundreds of millions of people at the exact same time without their servers literally melting? Well, it all comes down to structural evolution. In the beginning, we had 2-tier architecture. Super simple. Your client talked directly to one single server that held all the logic and the data, which is great for a tiny office, but terrible for the global internet. So it evolved into 3-tier architecture. This separated everything out into dedicated layers. You've got the client you interact with, the application server handling the business rules right in the middle, and the database server locked away safely at the back.
This specific separation, that's the gold standard for almost every modern web app you use today.
And this brilliantly illustrates what happens when we hit hyperscale. Because sometimes, even 3 tiers aren't enough for the sheer insane volume of global traffic. That's when you introduce multi-tier architecture. Tech giants deploy these things called load balancers. Imagine an incredibly efficient traffic cop standing in front of hundreds of application servers, taking in millions of incoming requests and perfectly distributing them so that no single server ever gets overwhelmed. Combined with massive clusters of databases all acting as one unit, this is exactly how Netflix survives millions of people streaming 4K movies simultaneously on a Friday night.
Honestly, it's so easy to see why this architecture absolutely conquered the digital world. I mean, it offers supreme efficiency. Everything is centralized. That means a company can just update a new feature overnight on their server, and boom, the next morning, millions of clients instantly have the new version. It's highly scalable, it's super secure at the server level, and it allows for massive resource sharing. For decades now, centralizing data and control has just been the undisputed champion of building technology.
Which brings us to Section 3, the breaking point, the flaws of centralization.
But here is the catch. For all its incredible power, speed, and efficiency, this model hides some pretty fatal vulnerabilities. When you put all your eggs in one highly efficient basket, what happens when you drop the basket? The absolute most glaring flaw of the client-server model is that it creates a single point of failure. If that central server goes down, whether that's from a cyber attack, a blown transformer, or just way too much traffic, every single client gets cut off. We have all seen this happen when a major platform like WhatsApp or Instagram just randomly goes totally dark around the world. On top of that, maintaining those massive server farms costs billions of dollars. And most importantly, you, as the client, have zero control. You're completely at the mercy of the central authority keeping the server switched on and granting you access.
To clearly visualize this shift, let's think about traditional banking compared to the emerging world of blockchain. In traditional banking, you've got a classic client-server setup. Every single time you swipe your debit card, it routes through the bank's central server. They hold the data, they hold all the power, and if their server crashes, well, you can't buy groceries today. Now contrast that with blockchain. Blockchain is a distributed network. Everyone in the network holds a copy of the ledger. There's literally no central server to crash. Verification happens by collective agreement, not because a central boss said so.
Section 4. The next paradigm. Enter the blockchain.
Those flaws we just talked about, the single points of failure, the lack of user control, the total reliance on central authorities, they weren't just annoying tech bugs. They actually sparked a deliberate technological rebellion based on the peer-to-peer or P2P networking model. You see, in a client-server world, there's a strict, rigid wall between the asker and the responder. But in a peer-to-peer network, that wall is completely smashed. Every participant, called a node on the network, is simultaneously a client and a server. You can request data, sure, but you also provide data to others. It completely flattens the hierarchy and kicks the central boss right out the door.
And the shift becomes incredibly clear when we compare them head-to-head. Client-server, that gives you centralized control. Peer-to-peer, that gives you distributed control. Client-server has that scary single point of failure. Peer-to-peer is incredibly resilient because, hey, if one node drops offline, thousands of others are still running the exact same system. But the biggest, most fundamental shift is trust. In the old model, you just have to blindly trust the central operator not to misuse your data or randomly shut down your account. In P2P, trust is distributed across the network's cold, hard mathematics.
So what does this all mean for you? What's the big takeaway here? It really boils down to one word: decentralization. When we apply peer-to-peer architecture to things like finance or data ownership through blockchain, it means there is no central server for a hacker to target. There is no single tech company that can go bankrupt and drag your data down with it. And there is no central authority that can arbitrarily decide to freeze your access. The power is pushed all the way out to the edges, distributed evenly among thousands of participants.
Let's wrap up today's explainer with a fantastic quote from our source material. Blockchain is not just a new technology. It is a deliberate and principled response to the limitations of the client-server world. Understanding that old system is really the only way to realize why the new system is so revolutionary. We've seen how the internet was built on centralizing power for the sake of efficiency. But what actually happens when a network can perfectly maintain security, agree on the truth, and operate on a massive global scale without any central boss whatsoever? Well, you'll just have to join us next time to find out. Thanks so much for learning with me today.